but you'll be able to use the calculator on the test next week, but I can't help you on that. Okay, calculator questions I can't help you with. So make sure you know what you're doing on the calculator. If you're still not there, practice on your own so that that's not an issue. Okay. Okay, so like I said, the last three new things we talk about are volume. Volume. Okay. Volume as opposed to area. Okay, so volume is when we talk about 3D shapes, right? So that's what we're talking about. We're going to be talking about 3D shapes. Here's the thing though. Like this is a 3D shape here. These two are 3D kind of like cone shapes. They're not going to give you a full shape. They're going to give you something that looks like this and say, when you do this, what 3D shape is created. Okay, so it's kind of visual. It's very visual, or abstract, I should say, more abstract, trying to see the process. So how are these guys created? Well, you take this, and I'll show you a little video. So I'll show you a video that the link down at the bottom is to the video I'm going to show you. So they're going to, like I said, you're going to start with area, and then from area, you're going to build volume. Okay. So let me show you the video. It's not, there's no sound on it. It's just the video. So they're going to start with the function y equals square root of x. Okay. So you see how it's revolving around the x-axis. It's revolving around the x-axis to create kind of a cup, right? Kind of a cup, three-dimensional cup. And then what we're going to do, oops. Okay, so there's the 3D cup, right? Let's see if I can make this bigger. There we go. So how are we going to find the volume? Well, that cup is a solid. It's not a cup. It's cup shaped, but there is no dip in it. It's a complete solid. It has no it's just a solid piece of there's no inside, right? For a cup, let's see. I got one right here. Like for a cup, there's inside, right? You could put things inside. This is not. Imagine this being solid. So all of this is solid, right? That's what that is right there. Okay. So how are we going to find volume of it? Well, we're going to use what's called the disk method. Okay. Disk method. Disk method says we're going to take one slice. So I'm going to take one slice of it, just like that. Creates a disk, right? Solid disk. Creates a solid disk. Okay. Based on that disk, we're going to find x and then the width of the disk. Okay, the radius of the disk. So the radius is equal to the actual function, right, that created it, right? Y equals square root of x. Okay, so here's another one. So here's the original graph. Square root 2 times the square root of x. Okay? Normally we'd say find the area of R. That's what we would say last week. That's what we did last week. Now what we're going to do is that area is going to revolve around the y-axis, right? And create a shape. Okay? So the reason I'm showing you this is not necessarily anything other than being able to see these figures, because you're finding volume for figures that you won't see, right? You can look at the questions here. That's the graph for number 1. That's a 2D shape. You can just look up here. You don't have to turn the page. You just look up here. Okay? We'll do it in a second. We're not going to do it right now. That's a 2D shape, right? So how do you find volume of that? Well, you're going to have to picture it in your head, okay? So that guy is going to look a lot like this guy right here, right? So that's what I talk about. So they're going to say two things a lot. They're going to say revolve around the x-axis or revolve around the y-axis. That's what they mean. When they say revolve, it means it creates that three-dimensional shape. Okay? A solid, no holes inside, nothing, just complete solid. So this would be like a solid, like a cone, right? Like a cone, like for the water bottles, the white cones. Imagine something like that, but solid, completely solid, no place in there for water to hold anything. Okay? So that's the kind of shapes we're going to create. That's the kind of shapes. So this guy here, today, this area is going to revolve around the x-axis. It's going to revolve around. That's how it creates a 3D shape. It actually comes out, goes back in, right? And creates a three-dimensional shape. All right? Which would look something like that. Okay. Okay, so what do we do? Well, here's our equation. Here's the guy we're going to use today. Every problem we have today, we're going to use. So there's two types. So here's the formula here. Okay, here's the formula. In this class, you don't get any formulas. So do you have to memorize it? Well, if you want to be able to do the problem, yes. Okay. So I always get that. Do we have to memorize? Well, on the end of this class, you get no formulas. They give you no formulas at all. There's nothing in stats. They give you a whole list of formulas you can use. But in calc, they don't give you any formulas. So if you want to be able to use it, you got to know how to use it. Okay. So I wouldn't suggest using it, reading. I wouldn't suggest memorizing it. Just understand where it comes from. Why is the radius there? Why is it squared? Where does the pi come from? Right? Those things. Right? Okay. So we have two. If it's a horizontal axis of revolution, so horizontal means this way. Horizontal means this way, like the first one I showed you, like the first picture I showed you. Okay? The radius is going to be top function minus bottom function dx. That's going to be the radius. So that guy is going to go right in there. Okay? Right in there. That's for horizontal. Horizontal. Over the x-axis, I should say. Or it won't always be the x-axis, but over this way. Okay? There's another one. Vertical axis of revolution. Goes this way. The second one I showed you, over the y-axis. That's a vertical axis of revolution. Okay? So this one we're going to go right function minus left function. Right function minus left function. That's going to be the radius. Okay. So before we do our first problem, why does the formula have a radius in it? Squared. Why does the formula have a radius squared in it? Where does that come from? Look at where do you think the radius squared comes from? Mm-hmm. Because the disk is a circle, right? Disks are circles, right? Disks are circles. That's where the radius squared. So if you have if you have a circle, what's the other part besides radius squared? Pi, right? And where is that guy? Goes in the front. Why does pi go in the front and not on the inside like radius? Pi is a number, yeah. Pi is a constant. So remember, constants go in the front. So do you have to put pi there? No, you could put it over here by radius. You could put it on the other side, but it's a constant. So just leave it on the outside. Okay? That's where all of those things come from. That's why we use radius squared and we use pi. Everything else, if you take away radius squared, and pi, it's just a normal integration problem like we've been doing all semester. Okay? So this formula, it's not bad. It's not a bad formula. It's relatively tame. Okay? Okay, so Let's look at the first problem. Now let's turn it over to example number 1. Okay. So let the region R, that's the green stuff. Green on mine, not on yours. Okay, that's the shaded part, I should say. Enclosed by the function f of x equals 2 times the square root of x, the x-axis, and the vertical lines x equals 0 and x equals 5. Okay. Find the volume of the solid generated when R is revolved around the x-axis. So this green area on mine, is going to revolve around the x-axis. It's going to come out like a 3D movie. It's going to come out and go back in, come out, go back in, and it's going to create an object. It's going to be like the first one I showed you, the on the YouTube video. Okay? That's what it's going to create. So we have to find volume of that thing. Volume of that thing. Okay? So let's look at what they give us. R is the green stuff. They give us a function here. They say this guy is that, right? It's always good to label everything. The x-axis. And the vertical lines x equals 1, x equals 0. So vertical lines x equals 0. That's the y-axis. And x equals 5. So that green stuff is bounded by all 4 of those guys. All right. Last week we said find the area. Now find the volume created when this guy revolves around the x-axis, right? Revolves around and revolves around. Okay? All right. Well, let's use our volume function. Volume equals pi. Pi always goes first. Integral a to b radius squared. Radius squared. So is this one going to be a dx or dy? Dx or dy? Because if it's dx, we need x's in here, nothing else. If it's dy's, we need y's in here and nothing else. So it's important. It's dx because it's a horizontal revolution. It's going across the x-axis, so dx. So we're just going to have x's in there, no y's. Okay. All right, the radius. Well, according to my notes, the radius says top function minus bottom function. Top function minus bottom function. So look at the green stuff. Look at the shaded stuff. The top function is the yellow. The yellow is this guy. The bottom is the pink. The pink is the x-axis. What is the equation for x-axis? Y equals 0. Y equals 0. So there we go. We got the top and we got the bottom. So we're going to put them in here now. They're already solved for y, so I don't need to worry about that. 2 times the square root of x minus 0, which essentially is just 2 times the square root of x. Squared dx. So before I can put it in my calculator, because it says I can use my calculator, I have to find the bounds. The bounds. Bounds are going to be the same as when you were doing area, right? The bounds are 0 to 5 because of those lines. Because of those lines, 0 to 5. Okay. Go to your calculator. What do you get? Don't forget to multiply times pi. Sometimes we leave that out. So the antiderivative, the integral from 0 to 5, 2 times the square root of x dx is around 14.0907, but I forgot pi. You can put pi in there with it, or you could just multiply your answer times pi. Just don't forget, though. Don't forget to multiply your answer times pi. Okay? Yeah, did you do something wrong? Oh, the squared. I forgot the squared, too. Yeah. That is a major thing. Yep. Thank you. 0, let me try this one more time. 0 to 5. 2 times the square root of x. Oops. Let me put some insert. Insert squared. 50 times pi. 157.0708. 157.08. We don't give us units, but it would be units cubed since it's volume. Okay. That one you can do by hand. You didn't need to use the calculator, but it said use the calculator, so might as well. Sometimes these will be non-calculator questions, and they'll give you stuff like this. So this one, not necessarily. Like if you square this, it would just be 4x. If you square this, you'd square 2, you'd square the square root of x, it'd just be 4x. So, okay. All right, so here we go. Let R be the area enclosed by the function f of x equals e to the x plus 1. Okay. The horizontal line, y equals 1, and the vertical lines, x equals 0, x equals 2. Find the volume of the solid generated when R is revolved around y equals 1. Okay, so y equals 1. So we got to label some things first. First thing is f of x. F of x is a exponential. Exponentials look like this. So that's f of x. Okay. Y equals 1 is this horizontal line. Horizontal line that passes through 1. That's this guy right here. And then there's 2 vertical lines, just like the last one. X equals 0. X equals 5. Okay. This guy is being revolved around the pink. So if it's being revolved around the pink, it's going to go this way. All right. Same as last time. It's going to be dx. It's going to be dx. Okay. Pi squared dx. So top minus bottom. Right. Top is the exponential, x e to the x plus 1. Minus, it's not 0 anymore, it's y equals 1. So it's going to be minus 1. The bounds are the blue lines, 0 to 2. So really, it's just e to the x squared. That's really what it is, because 1 minus 1 is just 0. Okay, calculator time. Times pi. 84.192. 84.192. So approximately 84.192. Was it 192? Yep. And you're done. All right. Okay, so now I want you to do number 3. No, I'll do number 3 with you. 3 and 4 are different. I'll do number 3 and 4 with you. Maybe I'll have you do number 4 together by yourself, but number 3. This one, no picture. We got to draw a picture. So find the volume of the solid form by revolving the equation y equals 1/2 x about the y-axis from 0 to 4. Y equals 0 to y equals 4. Okay. Y equals 0, y equals 4, y equals 0. Oops. Okay. Y equals 1/2 x. Y-intercept is 0, up 1 over 2. Okay, so the area bounded is right here. It's a triangle, looks like. This one's revolving around the y-axis. It's revolving around the y-axis. So that means this guy is going this way. It's revolving this way. It's not revolving the other way. It's revolving this way. It's a vertical revolution. Vertical revolution. Okay? So if it's a vertical revolution, it's going to be dy. Dy. So that means everything we put in there, everything we put in here has to be with respect to y. It means it has to say y. There has to be y's. There can be no x's in here. No x's in here. Okay? Well, if it's dy, we're not going to go top minus bottom. We're going to go right minus left. Right minus left. That's why a picture is important here. Whether you do it on your calculator or whether you do it by hand. Right? So the green stuff. So the right side, the stuff keeping it in on the right, is this line here. The left, what would the left be? Not y equals 4. That's the top. I would say y equals 4 is the top. What's the left? Yeah, the y-axis, x equals 0. Oops. 1/2 x. Okay. So it's going to be right minus left. But I can't put 1/2 x like that, right? Because that has an x. So I have to solve it for y, or for x, sorry. So y equals 1/2 x, divide by 2. X equals 2y. That's what I got to put in there. I'm going to put 2y in there, not 1/2 x, because that's with respect to x. And since this one is a vertical revolution, I have to solve it with respect to y. It means only y's. Solve for x. Okay. And then we said this guy right here is the y-axis, also known as x equals 0, right? It's already solved for x. It's 0. What are the bounds going to be? 0 is going to be this one, right? What is the top one going to be? 4. Yeah, the top one's going to be 4. Because bounds are top to bottom this time. Top to bottom. So 0 to 4. Okay. And then you can use your calculator from here. You can do it by hand or you can use your calculator. Let's see. 0 to 4. 2y squared 2 squared 268.083. 268.083. Is that what you guys get? Yeah. Sounds good to me. 268.083. Okay, that's the volume. Okay. All right, so now what I want you to do, I want you to do number 4. Try number 4. This one's going to revolve about the y-axis, just like the last one did. If we have some time, we'll do some. I'll give you some extra practice too, if we have some time. But for right now, just do number 4. Okay, so this guy's it's a quarter circle. The equation would give you a full circle, but it only said first quadrant, so we just want that quarter. Okay, so it's got to go across the y-axis. So the right is going to be the function y equals square root 16 minus x squared. The left is going to be the y-axis, which is 0, x equals 0. But the problem we have is that we have to solve this guy for x because it's with respect to y. So I started doing it here, I just didn't finish. So you just get you get x by itself, I should say. You just get x by itself. So 16 minus y squared equals x squared. You take the square root, you take the square root. Okay. So this is the guy that you want. This is the guy that you want. So you're going to have to use your calculator to see, do I need both positive and negative, or can I just use one of them? Do I need both, or can I just use one of them? There we go. Okay, which one is that? The positive, because it's in the positive, right? Everything in the first quadrant is positive, positive. So I just need the positive guy. So I'm going to put in here root 16 minus y squared minus 0 squared. And that's the guy that you're going to solve for. And then the bounds, sorry, I forgot the bounds. The bounds are going to be from 0 to 4. 0 to 4. Let's see. Oops. Nope. Zero to 4. Root 16. Let's see. Parentheses. 16 minus x squared. Yep. Wait, no, squared. Okay, let's see. 42 and 2/3. 42 and 2/3. 42.667. Okay. Alrighty. Okay, so I'm going to give you one more to do. One more, and then we'll be done. Okay, so find some space to do this one somewhere. Uh-huh. Oh, I forgot to multiply by pi. You are right. I did forget to multiply by pi, so the answer would be times 134.041. Yes, thank you. Yep. Yeah, that's a common mistake. Don't do what I did. And both answers will be on multiple choice tests because they know students forget about that. So you just got to be careful about that. 134.041. Okay, so last question. Here we go. I'll attach it to the notes too online. So when I post the notes, I'll attach it. But for right now, just copy down what you need. You don't have to copy down the whole thing. Just write down what you need. What do you need to solve the problem? If you need it, write it down. If you don't need it. So when you graph it, this is what it looks like. This is what the picture looks like. Okay, and it's going to revolve around the x, not the x-axis, but it's going to revolve horizontally around y equals 2. Okay, so the top is going to be the quadratic, x squared plus 2. The bottom is y equals 2. Yeah, go ahead. Go for it. Yeah, go for it. Okay. The bounds are the lines x equals 0 and x equals 4. So 0 to 4. And when you put all that in your calculator, you get 643.398. Okay. All right. Tomorrow we're going to do washer method because washer method is very similar to this. The only difference is there's a hole on the inside. A disc doesn't have a holes. Like if you think of a frisbee doesn't have any holes in it, right? But if I were to drill a hole in it, it would look more like a washer, right? A washer, like the metal washers. So that's the difference between those. Okay. So I'm going to, because technically these are both the same lesson. I just broke it up into 2 days. One is disc method, one is washer method. So tomorrow we'll do washer method. And then Wednesday I'll give you a time to, I'll give you an assignment that does both. So you got to decide, is it disc method or is it washer method? Because they're very similar. Okay.